Okay, I just got it larger. Here we go, that's better. You're making square invitations for a party. You start with a square piece of paper with 6-inch sides. You reduce both length and width by X as shown. Notice the picture. What is the area of the invitation? And justify your reasoning. Okay? Talk to your partner. Work it out. You're a team. Talk about it. Okay, talk about it. You reduce both its length and its width by X, as shown in the picture. Notice how many times you take off X. It's not 4 times. It's only 2. You only take it off 2 times. I like that people are actually using their paper. They're folding it. You're thinking about it. You're talking about it. You're drawing on it. What is the area? Think about our startup. We found the area of a rectangle. So you already should remember that formula. Are you working with your partner? In the same? Now here's a hint. X will be in your answer. So if you don't have X in your answer, if you've gotten an actual value, you need to put the variable X in your answer. Here's a hint. Hint. X will be in your answer. Which sounds crazy, but it will. Okay, have you guys talked about it? Why don't you talk about it, and then try to get your pictures to look like that, and then see area. What was the formula for area? A rectangle. We did this on the startup. What do you do with the 2 sides?
I do perimeter, but not area.
So we just did this. How do you get the 2 sides of area? Times what? Times what? How many numbers?
All 4 of them?
No, not all 4. 2. Length times width. Okay.
And that gets you area,
Length times width. You guys need to try it out. That's how you get the area. Length times width. Five, 4, 2, 1. Okay, there's a couple groups here that have discovered it. Okay, well, I'll give you 1 for being halfway. These girls are halfway. And then we have 2 for being right on, and 2 for being right on. Yes! I'm so impressed. Some of you actually figured this out. I know it's hard. It's kind of critical thinking. So I would like, the first groups that figured it out were these 2 girls. So Mara and Autumn. Will you 2 girls come up here, please, and explain what you did to solve it? And I think we can just we should be able to just write right on this diagram. Yeah, well, I wonder if we can make the tool like white. Yeah. Okay, so you can write, it's on white marker right now. But since it's recording, would you wear the mic, please? It's like a necklace. Okay. Could you do it? Okay, everyone listen up, please. And like Mara will explain.
Alright, so first we just realized that to find the area you times length by width, but since you're subtracting x, it's 6 minus x times 6 minus x.
And re-explain, how do you get 6 minus x?
Because you're cutting off x from both sides.
Subtracting x from both sides. It's no longer 6,
Times
right?
6.
We don't know what x is, so it is 6
minus x. So there's questions about that. How we get 6 minus x, because we're cutting off x. So subtracting. Keep going.
So then you times it out. So you get 36 minus 6x minus 6x plus x squared.
Okay, let's pause. Any questions? This is the double distribution that we're doing last time. Okay, keep going.
So then you add like terms. So you get x squared right below. Yeah, that's what you're doing. Minus 12x plus 36.
Okay, that's it up. I appreciate also that they put it in standard form. We talked about standard form last time, which is in descending power, x squared, x to the first, and then x to 0. Okay, everyone give them a round of applause.
How do I get it off? Let's just get pulled apart. There we go. Yep. Okay, excellent job and excellent explanations. Okay, raise your hand if you understand it now. Oh, there's still some people who don't, so that's when I said who has questions, you should have asked your questions. Okay, we have 2 groups over here, maybe 3. What part do you not understand? Do you understand it? Then you should, I didn't see your hands, I don't think. Okay, what about Daniela and Jessica? Is there anything you want me to clarify? Oh, you guys are just being lazy, I get it. Okay. Put the iPod away, please. It's also right here. Okay, the hardest trick is realizing what the side's length actually is, and it's a little abstract because you actually, it's not just a regular constant number, it's 6 minus x, because you take away an x from each side. Great. All right. Looking at time. Okay, everyone pull out a piece of paper. You can stay where you're at. Pull out a piece of paper. And if you've moved and you didn't bring your stuff with you, maybe your partner will share paper with you. And while you're pulling out paper, can you pass the rulers in and I'll grab the rulers. Okay, we're just going to go over some basic rules that if you felt pretty confident on double distribution, then today is everything we've been doing for the past 2 days. Okay, we're just going to write down some rules of what we just accomplished. The first one, let me get to my page. So the title is Multiplying Special Cases. Multiplying special cases. Okay, today I would like you to write your own essential question. The content objective says students will be able to add, subtract, and multiply polynomials. And the title is Multiplying Special Cases. So I want you to take a moment, and I've been helping you since beginning of school to write essential question. Now today I want you to try it on your own. This is a question we don't know yet, but we can answer by the end of class. And Ishmael, if you want to turn your desk so you can see. Turn your desk so you're not like straining to see. Write your own essential question. This is a requirement for the notes. This is a question we don't know yet, but we should be able to answer by the end of class. The title is Multiplying Special Cases. And we're definitely talking about adding, subtracting, multiplying polynomials. Okay, after your essential question, then please draw your column.